Fender 65 Reissue Princeton Reverb. Not anything wrong with it as it came in. This is not about fixing it. This is about making it better sounding, more reliable, and a real keeper. So we're going to go through here. We're going to get rid of the Illinois filter caps. We're going to move the screen grid resistors to the octal sockets. We're going to clean up some of the wiring mess. We're going to give some higher headroom to the phase inverter. We're going to eliminate some flaws of the cathodied phase inverter in these amps. We're going to deepen the tremolo, overall sweeten the sound, and just do some stuff to make this a little bit closer, not only to a great sounding mid-60s original, but in some ways better. The Princeton was handicapped by Fender in some aspects, so it would not be in competition with the Deluxe Reverb. So that if you owned a Princeton and you played your buddy's Deluxe Reverb, you would be dissatisfied and want to go buy a Deluxe Reverb. They handicapped the Deluxe Reverb in some ways, so that if you had one and you played your buddy's Pro Reverb, you'd want to buy the more expensive Pro Reverb. So on the non-vintage amps like these, I like to remove the handicaps, and at the end of the day, this thing should hang with any Deluxe Reverb. And there's some peculiarities of the Princeton mids circuit in conjunction with the 1x10 cabinet that comes in that I like to just kind of make things a little sweeter, a little less boxy, mid-range focused. I like to have them flush with the chassis. The only real reason to do this, other than the cosmetics, is you don't want this switch sticking out past the protection of the cabinet, so that the switch doesn't get damaged in transit, or if the amp is laid on its back or something. Like I said, it's almost purely cosmetic. But if you are having someone do work on your amp like this, I think it's all the little details matter. So when you get it back, all these things add up. Some of them you don't even notice, but it's funny how the brain picks up on things that we're not consciously aware of. Just a bunch of little things like that cumulatively. Sorry about kicking the tripod. A whole bunch of little things like that cumulatively add up to a nicer experience. And let's check the fuse value while we're here. It should be a 2 amp fuse for the US voltage, and it is 2 amp fuse. One little thing I like to do, it was in here like this so that you had to remove it to read the value. There's no polarity to a fuse. Don't let the audiophile salesman fool you. I just like to put it in so that you take it out and you can see the fuse rating. It makes no difference electronically. But it's nice. All right, well, I've got the board's still in place, I like to straighten these leads so that later I can push them down and they will come out on the other side of the board without any mechanical stress or tearing the very thin copper on the pads. I do that to all 4 filter caps. Now right here, these are the heater wires. And just like on the other reissue Fenders, heaters are where you do not want to use quick connects. It is too much current for the quick connect to handle. So these get pulled. And there's just enough length in these wires that they can be reattached and directly soldered to the pins of this power tube octa socket here. I'm going to go ahead and snip the quick connect ends off these. You can see a little bit of darkening beginning. Just the beginnings of darkening right there. Let's see if we can focus on that. You can see some discoloration starting. That's the beginning of excessive heat. Because there's a lot of current, the most current in the entire amp is through the heater connection. And this is not soldered to this. This is crimped. And then these are not soldered to the board. They're crimped to the board as well with these quick connects. And that is not a perfect connection. And whenever you have a lot of current going through an imperfect connection, some of that energy turns into heat. And when that happens, things which were not rated for the heat and current start to burn. And eventually it will burn the board. So it's good to head that off at the pass, so to speak. I have shown this before in a Deluxe Reverb video, a Deluxe Reverb reissue video, how I remove components from these boards without damaging things. So I'm just going to show it again on this one filter cap, the leads for this one old filter cap, and it's what I'm going to do on all the others. And I might show it again on a resistor, but I'm not going to show every one on these because it would just be a really long, repetitive video. And I'm sure this video is already too long for some people. People are always like, why do you talk so much? Why isn't it faster? Because I'm trying to impart actual information at a sense of the scope involved in doing this kind of work well. I'm not trying to compete with short attention span theater. So I'm just adding a little fresh leaded solder to the old solder there. This amp, I think it might be old enough that it has, from the look of it, this is non-leaded solder. It might just be nicer looking lead-free than Fender usually uses. Usually it's pretty gray. Anyway, adding that little bit of solder adds some flux to the old stuff, and then the old lead just pushes right through and pulls right out without any strain on these pads, because these old leads have a little J-hook at the bottom. If I try to pull up from the top, it would just rip, just make tears in the traces and pads. Now once I've got that up, I just take a little desoldering wick. You can use a desoldering iron for this, a desoldering tool. But I find that you spend as much time declogging them as doing any work with things like this. So if you're doing, you know, an IC or something really delicate, yeah, desoldering tools make a lot of sense. For this, a good desoldering braid does wonders. And as I've shown in other videos, once I get all these out, I'll go through here with a little ISO and get the old flux off. And I'm going to skip ahead a bit and show on this one, which is what I'll do later in all these others. Now that these leads are out of the way and there's nothing stopping me on either side, now I can just take that razor blade and very carefully cut the old silicone off without scraping up the board. And better to do a couple of little passes than to try to get all at once and end up cutting into the surface of the board. You want to just kind of keep the right angle, and you get a feel for it pretty quick. And it doesn't have to be perfect because I'm about to put new silicone on top, and it will actually adhere to itself pretty well, but I want to get almost all of it off. Sometimes it comes off more neatly than others, but that's a good point where I can add fresh silicone to hold the new cap in place. So let me do all the others and get to the same point, and then I'll maybe show how I remove a resistor or replace a resistor on this series. All right, now all the filter caps are out, and the next thing I'm going to do is I'm going to improve the sound and the depth and the range of the tremolo. So for those who complain that my videos are too long and skipped and didn't make it this far, they're going to miss out on this nice free tip. In a Reissue Princeton, the resistor in question is R14, which is right here. It is a 1 meg. It is on the output of the plate of the tube which is driving the tremolo, and feeds a 100 nanofarad cap, which then goes to the intensity, which is tied to the bias. And it is a 1 meg resistor. And that limits the depth of the vibrato, the tremolo. And one of the reasons is that they did not want this to be as deep a tremolo as the deluxe reverb. So if you had a Princeton, played a deluxe, you'd want the deluxe. Well, I'm going to change this 1 meg to 470K, which will dramatically increase the depth without getting into the whoop, whoop, whoop range. And this will be a much nicer sounding deep tremolo when you want it to. You still can control it with the intensity. And the way I'm going to get that resistor out without damaging the board is much like I did on those filter caps. I just snip the leads right at the body of the resistor, and then I bend them up so that they're pointing straight up, straighten them out, and then from the other side, I identify where that is. That's here and here. Just a little bit of fresh flux added to it, and then it'll just burn my finger when I poke it down from the other side. But you see that little bend there? Let's see, see it bend right there? If I tried to pull it from the other side, it would damage the hell out of this little pad. I'll do the other one. You can use a tool on the other side, but honestly, I've got so many calluses, both from playing guitar and from burning myself repeatedly, that I just use my finger and kind of close my eyes and think of England while it burns me. And again, just a little bit with a desoldering braid. And the other part of what we're going to do in this area, I'm not going to show everything I do on these, but I'll show this as a little thank you to everyone who watches these. The three capacitors in the tremolo circuit are a 22 nanofarad, a 10 nanofarad, and a 10 nanofarad. Actually, it's in this sequence, this one, then this one, then this one. And if we remove this 10 nanofarad and put another 22 nanofarad there, it will give us a slower minimum speed without dramatically slowing the maximum speed. Most people don't use the max speed, but we will do that. So it's this capacitor right here and here. So again, just a matter of adding a bit of fresh flux via fresh solder so it flows. And then I just kind of grab it with my finger on the other side and pull up. These are not crimped from the factory. These are straight. And the thing just pulls right out. And again, I'll get that old solder off. I've got a fresh roll of desoldering braid around here somewhere. I need to find. This one's about used up. And again, in a minute, I'll get in there with some alcohol and get that flux off. All right, those are all changed out. My vendor did not have a little film cap of the right value and voltage and lead spacing. There's a lot of stuff that's out of stock these days. But that ceramic disc cap I have in there is a Murata, and it's a 1 kilovolt cap, and it will never ever fail in this amp. I love these for the LFOs and Fenders. Just really nice, long-term reliable caps. And that 470K is in place, and it's another 1/2 watt carbon film, and I like to keep all the tolerance bands on the same side. So in most Fenders, that's towards the tube sockets. Now I've got some other resistors and capacitors to remove from this, and I'm not going to do a blow by blow, but I will show the board with everything removed that's getting changed out, and then things will magically reappear. And the important thing throughout, and I'm not going to show it on every one because, again, the video does not need to be very long. But here is that new resistor with its leads bent over first, and here's that new capacitor. And aside from my solder being slightly shinier than the factory, it looks factory. There's still a little bit of flux there. When I finish the entire amp, I'll go through with a soft bristle toothbrush and more alcohol and get all the flux off. But I hate when I see an amp that's been modded and it's just all hacked and malformed and butchered on the bottom, and on top side it's just a mess of hot glue and nonsense. And it gives those of us who try to do good work a bad name, because when I say I mod amps, most people instantly associate that with someone who doesn't know what they're doing, who ruins amps. And there's just there are way too many of those people out there ruining amps, including some with undeserved good reputations who charge an awful lot to damage amps. But nothing I do is snake oil. Nothing I do is mojo. I'm not promising that you'll sound like X guitarist if you have these mods. Everything I'm doing is explainable in terms of the science of how an amp works, and just the realities of what makes an amp long-term reliable, even with a little PCB. A little quick thing on that note. The difference between this Fender with its very thin, one-sided, low copper weight PCB and a very desirable 70s Marshall, which has pretty much the same crappy thin board with one-sided low-weight copper PCB trace, is that the Marshall kept all the things which generate heat off the board, and Fender keeps a lot of those things that generate heat on the board. And the filter caps, once the caps are good and have mechanical support on the bottom as well as the top and are soldered properly, will eliminate a lot of that. But all this stuff here I'm doing, moving the heaters off, moving the the 5-volt secondary for the heaters on the rectifier tube. Getting all this stuff off the board moves us much closer to the approach of a 70s Marshall, which is a very desirable amp, even with that very cheap PCB. I'm just getting the stuff that draws a lot of current off. So a lot of the problems with this PCB are being dealt with in this process, and one of the next things that are going to happen on that note is all the screen grids and the flyback diodes on the output tubes are about to move to the output tube sockets and get all that heat or potential heat off the board. Other things like some of these dropping resistors will stay on the board, but they're going to be mounted off the board about a ½ inch for better airflow, and if they were to burn, they won't take out the PCB with it. So they're less likely to burn with more airflow, and should they fail, they're much less likely to cause an expensive bit of damage. All right, the old solder is removed from the pins, the connections on the input jacks that are actually used, and I'll be putting some good quality Kester solder there, which holds up better. Got a little bit more to get off with some desoldering braid, but got the majority out. Anyway, the new Kester I'm putting in is going to be a much more reliable thing, because they're even with these being locked to the chassis, there's a bit of mechanical stress. You just want to make that work. Same for all the pot connections. And I've got some components removed from the tone stack. Those are about to get replaced. And here on this slope resistor, I'm going to replace that solder just for completion's sake. I'll show you something critical to do on these PCB mounted pots. It really helps out. Let me set up the tripod for this. All right, on these pins that come from the pots, before I solder them in place, I like to find my little screwdriver. All right, I like to bend the prongs over so that there is an actual mechanical connection to the board before solder is applied. I do that in reverse directions. You gotta be careful getting it started. And now that does not want to move even before any solder is applied. I mean, it's got the 4 prongs holding these cases to the shell as well, but this really lessens the chance that these solder joints will crack from stress. And some fresh solder there with that 6040 Kester. Just really reinforces that. And that is as solid as any PCB mounted potentiometer can be. And I'll do the same for these others, and I'll repopulate this. And that'll be time to move on to the main board. We'll go ahead and do this one. I can't really bend these over. Some input jacks, the little prongs are long enough that I can. But I happen to know that the solder that I use is higher quality than the wave soldering they do at the factory. I'm working hot and fast so as not to lift anything on these pads. These are stereo jacks being used in a mono application. So I'm not too stressed about the ring connections. They can stay factory. It's the tip and sleeve that matter here. And once I finish all this stuff, both these boards will get some more alcohol to get the remainder of that flux off. That's just part of the fun. Okay, everything that's getting changed out has been removed. I'm not going to tell you everything that I'm changing, because I don't want someone out there trying to do this exactly and then coming to me with all kinds of questions. I did this, but it does this, blah, blah, blah. I'm not here to give kits or how-tos because I'm not going to be able to support people who ask questions like that. So if you know what you're doing and you see this, you may say, oh yeah, that makes sense. If you have questions, just find a tech that you trust and have them do it. I just can't give out the secret recipe because then I have to spend all my time playing support technician for other would-be technicians. Anyway, the other side of the board, after all that is removed, is very clean with no damage. Everything has been removed carefully and well so that I can rebuild it at least as good as it came to me. It'll actually be better, but it's important that when you do work like this, even the stuff that no one will see has to be good. All right, it's all put back together again. Notice a lot of the stuff that was on the board, wires and components, has been moved off the board to the tube sockets. The octal tube sockets now have screen grid resistors. You can see one there underneath that white wire. And grid stoppers. This one has heater balance resistors. The filament secondaries are run directly to this octal socket. The 5-volt heaters for the rectifier are run directly here. Instead of having that big massive wire that was really stiff and in the way, just have the bias connection here and the HT connection here. And there's a lot less clutter. I could replace all the wiring from the power receptacle to the fuse and switch because it's very stiff, but that would be no real benefit to the client. New ground here for the HT center tap ground going there, as well as the wire from the amp, from the board. Before I put it all back together and put it in the tubes and bias it, there's one mistake this amp has that a lot of Fender reissues have, that in fairness, some of the originals have. All right, this is V2, the reverb driver tube. It's V2 in a Princeton. It's V3 in all the other 60s and 70s Fender amps which have reverb. And they have the cathodes joined, and they have the plates joined, and the grid, this green wire, they have looping around. That is a recipe for getting hum in this amp. What it needs to be, which is what the quiet ones are, is you have the cathodes jumpered across the tube, and the grids jumpered across the tube, and the blue wire, which is the plate, that's the one that needs to get looped. So let me redo it that way, and that'll get a lot of hum out of the reverb on the reverb recovery. Well, it's actually in the reverb driver, but when it exhibits itself as hum in the reverb, and as you turn the reverb up, you get more and more hum, and that's one of the primary causes of that. So let me fix that real quick. There you go. It's a simple little change, makes all the difference. Not a lot of people know about that, but now you do. All right, everything's back together. The reverb send wiring has been corrected. I actually had the brown and blue reversed on the primaries. I forgot that this Princeton had the brown and blue backwards to many other actual 60s Fenders. I just, out of habit, did it the wrong way, and I corrected that. So now the amp is sounding really good. It's very, very quiet, and the reverb sounds great. The trim is very useful. I'll give a real playing test when you can really hear it, because this is just a lav mic, but... that new minimum slow speed. Still goes up fast. Now, Even with the increased depth in the circuit itself, there's not as much depth as I want to get, and that's because these output tubes, they're a pair of Tungsol 6v6s, no problem with that. Apex matched from CE distribution. Now, I use CE distribution for a lot of things, but I have not been impressed with their Apex matching. And these two tubes are mismatched by a factor of 10% idle. One's idling at 58%, the other one's idling at 48%. And that's with the bias at the minimum in this amp. So it's almost at 60% on one of these tubes with the bias range at its bare minimum. So I'm going to power it off. He also supplied the old original groove tubes labeled 6v6s. I'm going to see how those set up. And I'm going to make sure that the mismatch is the tube and not the amp itself, though with my experience with the Apex matching, I have suspicions it's just a poorly matched pair, matched at a lower plate voltage and current draw than you actually get in an amp, even a little Princeton. The brand new Apex tested Tungsol 6v6s were mismatched, as I said, and at the coldest bias, one was at 60%. Then I put in this pair of groove tubes that the amp originally came with, and they were very well matched to each other. But again, the minimum bias setting on the amp, they were at 60%. I couldn't cool them off any more than that, and I just couldn't get the depth I wanted. I put in a tube store matched pair of Electro-Harmonix 6v6 GTs, and very well matched, at least in new condition. And with the bias at minimum, they were at 45% idle. So now I've got them about 52%, and the tremolo depth is really nice. So I'm very pleased with that, and I'll let this do some burn-in testing, and then I will do some real playing tests with it with a different video.